Okay, so we're going to talk about the last question from the problem solving section, as I think that was the one that caused us the most difficulty. So it asked us to expand p plus qx all to the power of r. We were told that p was less than q, which was less than r, which was less than 8. That may come in handy later. I've done the first expansion bits for you, so that's just generating using the formula for binomial that we know about. We were also told that the constant term was 16. So the constant term is the one that doesn't have any x's in it. So we therefore knew that p to the r was equal to 16. Okay, that almost becomes equation 1. We were then also told that the coefficient of x squared, so everything not including the x, was equal to the coefficient of x cubed. So we also had equation 2, which was r minus 1, p r minus 2, q squared, all over 2 is equal to r minus 1, r minus 2, p to the r minus 3, q cubed, all over 6. Okay. We were also told that it had integer solutions. Now, looking at this, I have 3 unknowns and only 2 equations, and there's no other information I know. So I'm not going to be able to get any of these out unless I make a bit of an educated guess here. So this is the one that's going to be a bit easier to do so. So we know that we have integers, so we know that p to the r must equal 16. So that could be, say, 4 squared is equal to 16. But that wouldn't work because in this case r is 2 and p is 4 and r needs to be bigger than p. So this one doesn't work. Another way to get 16 using integers is 2 to the power of 4. That does work. So that would tell me that p is 2 and r is 4. Okay, so far that's all I've got. There's no other way of making 16 using integers, so we've covered our back with that. Okay, then we need to move over to this one. There is some simplification that we can do before we worry too much about substituting these in, if I'm honest. The first thing that I'm spotting is that there's r and r minus 1 on both sides, so I can divide by those. I'm also noticing that I could potentially times by 6 to get rid of these fractions. So this one becomes 3 p to the r minus 2 q squared, and this one just stays as p to the r minus 3 q cubed. Again, still some simplification that I want to do. I could write p to the r minus 2 as p to the r over p squared, and using our laws of indices, and this one p to the r over p cubed, and then I've got q cubed. Then these go. Also the squared and the cubed, I can just divide by q squared to leave me with 3 over p squared is equal to q cubed over p cubed. That one works. I can then times by p squared and simplify these. Oh, sorry, that should be just q on its own, so I've divided by q squared. Times by p squared is equal to 3 over q over p. Oh, but I've made exactly the same mistake as I did before. I forgot about the r minus 2 over here. So that didn't get cancelled at any point. So I'm popping that back in. Okay. At this point I would substitute in what we know p and r to be. So we get 3 is equal to q over 2 times by 2. So 3 is equal to q. That works because that makes p being 2 less than q being 3 and r being 4. Okay. So the question that I'm going to set you for the diagnostics is really all along the lines of knowing information about your coefficients and doing something with them. So what you want to do is you want to expand out up to the amount that you're going to need. Like I knew I was only going to need to go to x cubed because that's all I knew any information about. So expand it all out in the way that you're used to, and then drag the information from it and structure it into a formalised answer. Okay? Yeah, so I hope that helps with your diagnostics. Good luck.